All right, here's a change of rate problem. It says, I've already drawn the picture, I'll read the question. It says a rocket is tracked by a radar station, that's the radar station right there, that is on the ground 5 miles from the launch pad. Here's the launch pad right here, the rocket. How fast is the rocket rising? So I've already labeled my variables. This is your y, this is your x, and then the distance between the rocket and the radar station is your d. Notice it's going to be a Pythagorean theorem. So I've got x squared plus y squared equals d squared. And it's asking how fast is it rising. So that means they want to know what dy dx is. How fast is it rising? When it's 4 miles high, and this is the instant that it's, I'm going to write this down here because we use this at the end, the instant when it's 4 miles high, so y equals 4, and the distance from the radar station is increasing at a rate of 2,000 miles per hour. So that's the distance, that's the dd dt equals 2,000 miles per hour. I'll put 2k. So that's what they want us to find. So first of all, notice that in this classic rate of change problem, the first thing to do is define an equation, and then a lot of times you have to find another equation, but in this case I don't need another equation because x, 5, is not changing. So this I can just plug straight in and call this 25 plus y squared equals d squared. And now I can do the implicit differentiation. So I'm going to differentiate this with respect to time. So I like to write it like this: d dt. That's what I'm doing.
That's right.
And when I do that, what's the derivative of 25?
0.
That's 0. It's gone. So this is going to be 2y dy dt equals 2d dd dt. And now I can plug in, now that I've done that, I can plug in 4. I'll go ahead and draw some lines here. I'm going to plug 4 in for y. I'm going to plug 2,000 in for dd dt. And I still need to find one of my other variables. Well, I can find that because I see that y is 4. So if y is 4 and x is 5, what's d? Don't say 3. It's not a 3, 4, 5 triangle anymore because the 3 and the 4 aren't in the right place.
Yeah.
So this is going to be 4 squared plus 5 squared equals d squared. So d equals the square root of 16 plus 25, which is the square root of 41. So that's what d is. That's maybe the hardest part of this problem. That's the square root of 41. And now I can plug all those things in and solve them. I'll do that in a sec. Alright, so there's the equation when I plug stuff in. So I'm going to I'm going to divide. Notice what I'm not doing is I'm not multiplying things out yet. This is a little trick that I like to tell people. Simplify before you complicate. So I'm going to just write out, notice I'm going to have to divide by 2 and 4, which is of course 8, but I'm not even multiplying those out because when I divide both sides, now I can see, oh look, those 2's cancel. And 2,000, 2k right there is really 2,000. 2,000 is divisible by 4 as well. What's 2,000 divided by 4?
500.
What is it?
500.
Yeah, I thought you said 700. Yep. So it's 500 times the square root of 41. And see, I didn't even have to multiply things out or punch it into your calculator or anything like that.
Okay.
So simplify your fractions before you complicate them. In other words, don't start multiplying things together until you absolutely have to. Because a lot of times when you do, like in this case, when you put that together, it will simplify it and it's much easier that way.